All right. Welcome back from spring break. I hope you had a good time off. I hope you're staying safe, healthy. Definitely isn't what I expected at the start of the semester, but we'll figure this out together. One thing I ask is please communicate with me. If you're having trouble getting things done and you are trying, please let me know. Talk to me. We'll figure out a plan together. I'm going to try to be consistent. So every Tuesday, Wednesday, and Thursday for the rest of the semester, Algebra 2, you guys will have 2:30 in the afternoon is your time where I will post a Google Meet in Google Classroom, and you can get on each day and talk to me if you have any questions. Okay. Now, if that time doesn't work for you, I know some of you maybe are working. Some of you might not have access to internet at that time. Please reach out. Send me an email. Send me a message on It's Learning. Figure out a way that we can talk about what your questions are. Okay. I will respond to you. You got to reach out to me. I'll do my best, but please communicate. Don't wait till the end of May to reach out to me for the first time. Okay. I'm going to try to get on those of you who haven't done anything yet, but um, please try to hold yourself accountable, do your best, and I'll do my best as well. Okay. So you might notice on this screen, Web 2.0 calc.com. This is a pretty standard scientific calculator. I mean, 5 times 6 equals 30, just like our normal ones. It's a little different layout than the ones I had in class, but it's very similar. You might notice sine, cosine, tangent over here. Some different things that we can do. Here's our log buttons, square root, cube root, basically all the things we've used so far in this semester. And there's going to be a few things you might need a scientific calculator. Now, if you have an iPhone, you also can just use that calculator, okay, except you're going to have to turn off your orientation lock, turn it on the side, and that'll give you more options, okay? So from time to time, you can either use your phone calculator, you can use this website. If you have your own calculator, that's great, but I know not all of you do, okay? If you have Android, it's also possible to get that scientific calculator. I believe you turn it on its side as well. I'm just not as familiar because I have an iPhone. So the first thing I want to talk about, today's lesson is entitled The Fundamental Counting Principle, okay? So we're going to start off here, 3 times 2 times 1. Now this one's pretty easy. You guys could do just 3 times 2 is 6. 6 times 1 is still 6. So 3 times 2 times 1 equals 6. Now, if you weren't as confident, maybe you want to do it on the calculator. 3 times 2 times 1 equals 6. We see it equals 6. Now our next one, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so it's the same exact thing, except now we're starting at 8. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we hit equals, and we get 40,320. Okay, now, obviously that one would have been more challenging to do in your head. It's still possible, but there's no reason to force yourself to do that in your head. Just use a calculator, that's fine. Now, obviously you can tell I'm still working on my writing skills with the computer, but I'll get better. So, if we look here, there is another way you could write this. 3 times 2 times 1. Another way we can write that is 3 with an exclamation point. Now, what that means, that doesn't mean 3. Okay, it's not like we're really excited about 3. That means 3 factorial. Okay, so 3 factorial. If, let's see, I can type this out for you. Here we go, sorry. 3 factorial. Okay, that's how you would read that. And basically what it means is just 3 times 2 times 1. You start at whatever that number is, and then you count down, and you got to multiply each of those. So 8 times 7 times 6 times 5 times 4 all the way to 1, that would be 8 factorial. Okay, so anytime you see that 8 factorial, that means multiply starting at the number that's given here and multiply down. Now, on this calculator, we typed in 8 times 7 times 6. That's kind of tedious, especially if you had a number like 15 factorial. The other way you can do it, just start with, let me clear it, start with 8, then on your computer, put the exclamation point in, and you see it reads a factorial, we hit enter, and we get the same answer. Okay, now once again, if you're using an iPhone, you can do it, turn it on its side, and so 8 factorial, we're going to start by hitting the 8, and then you'll notice over here It's kind of hard to see with the glare, but there's an x factorial right here, the second from the bottom all the way over to the left side. We hit that button, and hopefully you can see. Sorry, my answer is 40,320. Okay, so I don't care which way you use to calculate factorials, you'll need to use one of those. Now, we go back to our example and we scroll down to the next part. There's going to be, it says here, many real-life problems where we want to count the number of possibilities. Okay, so this is called the counting principle. We're figuring out how many possibilities there are. So it says, for instance, suppose you own a small deli. You offer 4 types of meat, ham, turkey, roast beef, and pastrami, and 3 types of bread, white, wheat, and rye. Okay, so you've got 4 choices of what meat to have, 3 choices of what bread to have. It says, how many choices do your customers have for a meat sandwich? Now, in this sandwich, we're assuming you have 1 type of meat and 1 type of bread. So, one way, you guys have all done this before, a tree diagram. As you see here, your choice of meat could either be ham, turkey, roast beef, or pastrami. And then from each of those, you could have 3 choices of bread. So that gives us ham and white, ham and wheat, ham and rye, turkey and white, turkey and wheat, turkey and rye, etc. Now, if we count those, that's 12 possible choices. And with this example, it's pretty easy to make that tree diagram. You guys know how to do that. I'm sure most of you could do that on your own. But an easier way is something called the counting principle. If we look right here, it says another way to count the number of possible sandwiches is to use the fundamental counting principle. We have 4 choices for meat and 3 choices of bread, so the total number of choices is 4 times 3. So to think about that, I would recommend we have a blank for the meat. Ooh, I gotta get better at this. And we have a blank for the bread. And then we just fill them in. So it's 4 types of meat times 3 types of bread, and we get 12. Now, that's when we have 2 events. Okay, say we had a third event, we can just multiply that on as well. Okay, so our third event here, say we want to make it more interesting, and we want to add cheese. Now, at this place, they only have 2 types or 2 options. You can either get it with cheese or without cheese. Okay, so if we added a third type, cheese, that basically is yes, do I want cheese, or no, I don't want cheese. So if we think about it, it's either yes or no. So that's going to be 2 choices. So I would multiply 4 times 3 times 2. That gives me 4 times 3 was 12 choices. Now if I have the choice on each of those to either have cheese or not, I times it by 2, and I get 24. Okay, so the counting principle, in this case, it was 4 times 3 times 2. It doesn't always count down by 1. That just happened to be the case in this example. But if we think about it, each of these, I could also have either cheese or no cheese, and I could do that for each of those. So that's why it doubles. Okay, so the next thing I want us to talk about, that's the fundamental counting principle. And the next thing we're going to talk about is permutations with repetition. Sorry. So if we go here, the definition of a permutation, if you look, I'll highlight it for us. Let's see if I can do this. Oh. All right. So a way, especially one of several possible variations in which a set number of things can be ordered or arranged. Now that was the general definition of permutation. Down here it says mathematics. Okay, for that one, the action of changing the arrangement, especially the linear order of a set of items. Now linear we know means line, so the order that they are is how we're going to do this. So if we go back now here and we think, it says find the number of distinguishable permutations of the letters in Ohio. And then we'll talk about Mississippi next. Now, it says here, permutations with repetition, sorry. What that means is the word Ohio, if I would reorder those letters, how many different ways can I reorder the letters? Now, Ohio has 2 O's. If I write Ohio and then I flip the O's and I rewrite it again, it looks exactly the same. Distinguishable right here, we're considering that to mean they look different, okay? If someone walks in, these two O's, if I switch them, nothing changes. They don't know that I switched them. So that does not count as a distinguishable permutation, okay? So basically here it says we're going to take the total number of objects, or in our case letters, that's n factorial, or here you'll see the total number of letters, factorial. And then on the bottom we have to put how many letters repeat. Now what I mean by that, if we go down here, Ohio, it's 4 letters. So they start with 4 factorial. Now 4 times 3 times 2 times 1, or if we do that on our calculator, 4, hit that exclamation point, factorial, gives us 24, okay? So 4 factorial is 24. Now, O is repeated 2 times. That's the only letter that's repeated, so 2 factorial goes on the bottom. 2 factorial is just 2 times 1, which stays here as 2. 24 divided by 2, that's going to give us 12. Okay, so 12 is our total number of distinguishable permutations here for this first one. Okay, now Mississippi, this is a much more complicated one because there's a lot more letters, and as you know, MISSISSIPPI, right? Probably one of the most complicated words you learned to spell when you were younger. And if we look here, there's 11 total letters. The I is repeated right here 1, 2, 3, 4 times. The S is repeated 1, 2, 3, 4 times. And the P is repeated 2 times. So right here we write it 11 factorial. That's how many different letters there are. Then 4 factorial to represent the I, 4 factorial to represent the S, and then 2 factorial to represent the P. Now be careful, when you type this into your calculator, we can't just do 11 factorial divided by 4 times 4. Okay, we gotta solve it order of operation style. So we can go 11 factorial, and we'll start with that. 11 factorial. We hit enter. We get 39,916,800, which, as you can see, we have right here. Then 4 factorial, we already know is 24. We know that's 24, and we know 2 factorial is 2 from the last problem. But in order to solve this, we need to multiply all of those together. So let's take 24, oh, I forgot to clear it. 24 times 24 times 2, we get 1,152, okay? So that is what we will use in the bottom. We'll divide this 11 factorial by that 1,152. And then we hit enter, and then we divide by 1,152. And you see we get 34,650 different permutations. Now, obviously that's got a lot more different permutations because there's a lot more letters involved. Okay, so I don't expect you to be experts at this yet, but please rewind the video, try to watch some parts again, get on at 2:30 today and ask me questions. There will be a brief It's Learning assignment today. I think if you follow this video and you use these notes, the keys in the video, you'll be able to do it. But good luck, and please let me know if you need any help. Have a good day. Thanks.